Have you ever believed that a simple electrical plug could be turned into a homemade antenna? It sounds a little crazy at first, I know. But the truth is, it actually makes a lot of sense, and more importantly, it really works. I've tested it myself and the result might surprise you. So if you're curious how something this ordinary can do something this unexpected, let's roll up our sleeves and find out together. And do you believe that a single razor blade can actually be used as a signal receiving component? At first glance, it's just a thin strip of metal, nothing special at all. But because of its material and extremely sharp edges, it can interact with electromagnetic signals in a very interesting way. When applied properly, it can help capture weak signals and support simple antenna systems, proving that everyday objects can be surprisingly capable. Next, I added 2 more pieces of electrical wire to complete the setup. These wires are used to connect the positive electrical plug to the signal receiving component, which is the razor blade. This step is important, because it allows the signal to travel smoothly between the antenna source and the receiving element, forming a simple but functional connection. Alright, the signal receiver is now connected to the electrical plug. Next, we'll move on to making the connection that links this setup to the TV. This here is a standard electrical outlet, but in this project, it becomes surprisingly useful. First, it works as a solid base for the antenna, helping keep everything stable and well positioned. Second, it allows us to connect a coaxial cable, which is used to carry the received signal directly to the TV. By combining these two functions into one simple component, the setup becomes cleaner, more practical, and much easier to work with. In my hands right now is a coaxial cable, a very familiar component in television and signal systems. This type of cable is specially designed to transmit signals with minimal interference, thanks to its layered structure, which includes a central conductor, insulation, shielding, and an outer protective jacket. Because of this design, coaxial cable is excellent at carrying weak signals over long distances while keeping them stable and clear. That's why it's commonly used to connect antennas, TVs, and receivers, making it a reliable bridge between the signal source and your television. After connecting one end of the coaxial cable to the electrical outlet, the next step is straightforward. I'll take the remaining end of the cable and connect it directly to the TV's antenna input. This final connection completes the signal path, allowing the signal captured by the antenna system to be delivered straight to the television for reception. To make connecting the coaxial cable to the TV easier, I'll add two F-type connectors to this cable. One is a straight F connector, and the other is a 90-degree angled F connector. This setup gives more flexibility when plugging into the TV, especially in tight spaces, and helps reduce strain on the cable and the TV's antenna port. Alright, that's everything finished. Now I'll take this device out and test it right away to see how it performs. Before connecting this device to the TV, I want to take a moment to check the screen first. Right now, as you can see, the TV is showing no signal at all. I do this for one simple reason: trust matters. When you see the starting point clearly, you can believe the result that comes after. There's no trick here, no hidden setup. Just a real test shown step by step. That way, whatever happens next, you'll know it's genuine. Just a few seconds after connecting the device to the TV, the television signal was already picked up. That's a good sign, but to be completely sure, we shouldn't rush to any conclusions. Signal stability is just as important as signal reception, so we'll wait a little longer and keep watching to see how well it holds up over time. We've been waiting for a while now and nothing unusual has happened so far. To be absolutely sure, I'll unplug the connection and plug it back in once more to see what happens. And this brings us to the end of today's experiment. From a few very simple, everyday components, we've just seen that something unexpected can actually work, and work reliably. This project was never about replacing professional equipment or claiming miracles. It's about curiosity, testing ideas with your own hands, and understanding how the things around us really behave. When you take the time to observe, to test, and to verify results step by step, trust naturally follows. And that trust is what turns a simple experiment into real knowledge. If this video sparked your curiosity, I encourage you to keep exploring, keep questioning, and keep building safely and responsibly. Because sometimes the most interesting discoveries don't come from expensive tools, but from the courage to try something simple and see what happens.